Alright, this video is a continuation of the Analog Robot 1. So in this video, let's just start up a new Simulink model. In this video, I want to take the phototransistor that we built in the previous video, and we're going to integrate it into a comparator circuit. And this comparator circuit will then be used to drive a H-bridge motor driver. We're actually going to build 2 of these per motor driver, and but that will be in the next video. So first I want to start off by import, actually I'm going to start off by opening up my library that I made last time. And I'm going to import that. Sure, import right on top of each other. And I'm just going to import that. So this is our phototransistor. Again, I'm going to open it up, and this is the circuit from the previous video. All right, now I'm going to start using some of the shortcuts. So I'm going to type in knob, and that'll import our knob. I still want to be able to control how much light or how much luminosity goes into that. And then I'm going to type in constant. And we'll just connect that right up. Now I want a voltage source. If I can spell it correctly. Voltage source. I want that to be 5 volts. And electrical reference. Always have to have a ground. I might as well just connect that. Now I want the solver configuration. And I also want a resistor. Control R to rotate. Oh, fine, be that way. Type 1, Control R to rotate. And we're going to just right click and grab this guy over here. Connect that. Oh, a little off centered. So I'm going to double click on this. I actually want 1 kilo ohm. And connect the VCC. So this is our basic, oh, I forgot, real-time synchronization. I want to be able to run this in real time. Click on that. I want to go from 0 to 1. Oops. And I also want to connect it to that block. Okay, I'm going to change the name of this from constant because that's just boring. Loom. All right, so this is our basic common collector phototransistor. So one of the things that's actually kind of nice to be able to right click on that, hit parameters, is to be able to see what resistor value this is. So we can go up to the block annotation. We're going to scroll down to R's. So I'm going to import that, scroll that over. So this will actually display. So if I click apply, you can see it just imported the value. So it's 1. But then I also need units. So I'm going to, scroll right past it. And I'm also going to import our units. And so if I have this, this is basically the way that it's going to be arranged in the schematic. So if I have this, I'll have 1 on top and then kilo ohm underneath. That doesn't look all that great. So I'm going to go back up here. I'm going to put it on the same line, put a little space in there. Click apply. Now that's nice, 1 kilo ohm. I think it's a little cleaner to read. All right, so we're going to right click. We need a voltage divider. Right click and hold. And I want to actually change these to 10K. Change that to 10. And let's actually pull this down a little bit. Connect that. Connect that. Connect that. And I'm going to get the comparator. I don't want to input offset voltage, and this is comically small, so I'm going to make that a little bit more realistic. And I want to rotate that twice, invert it. I actually want the inverting input there, and then the non-inverting input here. Move that down. Oh, there you go. Now the idea is that the common collector does not invert, so I could use a common collector, and then I would just use this as the this would be the voltage reference, and this would be the input. But 6 of one, half dozen of another, it doesn't matter. Essentially, this will all work. Basically, what I want to do as the luminosity input increases beyond the 2.5 volts, I've got 5 volts VCC, and these are just equal. So this is going to be a reference of half the voltage input. So once this once the output increases to above 2.5 volts, this will turn on. And so I just need another resistor. I'm just going to cheat, grab that, double click on it. So and we'll just do 4.7K just for something different. So that's going to be my pull-up resistor. And connect that to VCC. That's not quite straight. That does bother me. Meh. That's good enough. Now I also want a voltage sensor. I want to be able to measure the output voltage of the comparator. Well, invert that. And I'm actually going to put a reference over here. Connect. I want a physical system to Simulink connector or converter. And then I want a scope. And 1. Connect that. All right, so this is basically the circuit. That the amount of light, as the amount of light increases going onto the phototransistor, this will output a high or low voltage. So this will actually bring it up to either VCC or ground. And let's see, we're going to slide this over, zoom out, move that over. Gotta make some space for the scope. Move that off to the side so I can actually see it. And I want this to open up at simulation. Click OK. Then let's do 20 seconds. 30 seconds is too long. 10 seconds is a little too short. I want to click run. So it's going to compile. Then it starts. So I'm below the threshold. Now the voltage is 0. And right there is about the threshold. That goes up to 5 volts. It'll auto scale once we get to the end. And so the threshold's right about 4.5 or so. Yep, goes from 0 to 5. Well, almost 0. All right, so this is ultimately not a super impressive circuit, but it's I think it's about time we actually had a short video. In the next video, I'm going to take the output from the comparator. I'm going to use it to drive a simulated motor. So this is going to get into the multi-dimensional aspect of Simscape. We're going to have an electrical side of the motor and a mechanical side of the motor, and we'll see how the amount of light, and we'll be able to see the velocity of the RPM. So we'll be able to see the motor turn on and off. Before we finish off, I want to do one more thing. Whoops, that was not it. All right, so the next thing I want to do is build this into another subsystem. So the idea is that when I go into the next video, I just want to have one block that I import. So again, we're going to have the control knob and an external voltage and all these other bits. But here, it's just going to be simplify this down to one block. So again, I'm going to have the luminosity input, electrical reference, the connector, VCC input, and then the output. So it's going to be minimize the amount of mess, because I'm going to eventually have 4 of these. So if I had this 4 times, it would just get messy. And so we're going to highlight all the bits that I want. All right, then right click, create subsystem from selection. Pop. All right, so I'm going to move the collector to the top. And I want the comparator output over on this side, and the luminosity input. So now I've got I don't need to actually attach a electrical ground. It's going to be internal. So here I've got the Simscape inputs and outputs, and then here's the, let's clean this up a bit. Move this guy up there. Yeah. Put you on the other side. All right. So I've got the Simulink model input and then the Simscape model inputs and outputs. So let's relabel this V out. C luminosity. Light comp for light comparator. Sure, let's go with that. All right, and just out of good habit, let's run it again. So you never know. So that's down 0 volts. No. Below the threshold, above the threshold, below the threshold, above the threshold. All right, I like those outputs. All right, so the last thing I want to do is cut this out of the model, and I want to paste it into my library. So what I'll do is then copy from my library and paste it right back in. And there we go. I'll clean this up a little bit. All right, that is the simulation for a subsystem light phototransistor with a comparator output. So this is basically going to take light input, and it's going to be a binary high or binary low. Here I've got the photodiode, Darlington transistor, and resistor from the previous video. So this is a common collector amplifier for the photodiode, and is outputting a voltage to pin 5, which is the non-inverting input. I've got my 10K pair of voltage divider that's connected to pin 4, the inverting input. And I've got my 4.7K resistor, pull-up resistor from the output. And all this is doing is I'm using the LM339 quad comparator. Ideally, I should have all these other non-used pins tied to ground, but I'm not doing anything so sensitive that it's really going to throw it off. So there might be some internal noise if you're doing something else. I've got channel 1 connected to the output of the comparator, and channel 2 is measuring the voltage off of the photodiode or the phototransistor amplifier. And as we'll see, I'm going to wave my fingers or my hand over it, and we'll be able to see the voltage at the output of the transistor, as well as the output of the comparator circuit. And it's a very nice binary output, on or off. So the yellow channel is channel 1, and that's the comparator output. And the blue is the channel 2, that's the output from the phototransistor. As you can see, I'll bring my hand over slowly so you can see the voltage changing. And right there, right around. Yep. It's fun. I don't have any positive feedback going, so right at the transition stage, you can see it's actually a little noisy. But this is going to be a situation where it's not a very subtle changing state of light. It's going to be either highly reflective or a very not reflective surface. So it's very unlikely to get at that stage where it's very noisy. But here you can see I'm just waving my hand back and forth, and it's creating a very nice 5 volt output or 0 volt output. If I wave my fingers across it, I can actually count how many fingers I have. Well, not counting the thumb. Oh, got my thumb in there. All right, so for the next video, we're actually going to connect the output from the comparator to the H-bridge motor driver, and we'll turn the motor on and off based off of the amount of light that the photodiode is detecting. And then after that, we'll build up a pair so we can actually control the direction of the motor. So we can go either forward, reverse, or stop. All right, I hope this was a useful video, and I hope you learned something.